Simple addition. What is 5 plus 5? And it gets stored in 203. Did something wrong here. Okay, I was thinking Atari. This is a different register on the Commodore 64. So you have to be careful where you're storing numbers. Memory location 203 is for current key press, which wasn't my goal here. Just trying to make a simple addition program. So I know these are unused. Should work after I system it. The result is 10. So 5 plus 5 is 10. So whatever number you put in here will be stored in 679 every time you run it. That's the kind of stuff I wanted to go over. I haven't got anybody joined yet. So essentially I'm just talking to myself right now. Unless there's people watching, of course. So 20 plus 5 is 25. Subtraction, you just set that carry flag. You use SBC for subtraction. And run it. I think I need to set this double size. Run it again. And peek into the register again. Now we got 15 because 20 minus 5 is 15. So if anyone can hear me, I'm going to test. We'll need to start doing tests for that. See who's all here. I saw 2 viewers earlier. Weird. That's the thing when you're doing Google Hangouts is it takes time for people to show up. If you haven't done one in a while like me, it's been about a year or so. Something like that. So I'll be waiting for you guys to answer. I saw 2 people come in and out. If something's wrong with my screen, okay, so I just wrote, how is the screen that you're seeing? If there's any issues, let me know. It's really hard to see what you guys are seeing. This is CBM Prg Studio. It's an editor for assembly language for the Commodore 64-bit computers. I'm just doing simple programs. The whole session of this was probably to try to get people started writing their own stuff. I don't see a lot of that going on YouTube. I take it either people don't know how to do it, which is the whole point of this hangout, or it's either they don't know or it's just too complicated somewhere along the line. Like they're interested in doing it. Like when I first started it, it was very over my head. You know, it was confusing. The main thing you always want to understand is your computer is organized by memory locations. Every computer is different, but all 8-bit computers, if I could say this without getting slammed on this, they all operate under the same theory that you can write what you can write on one computer, you can write it and transfer it to another computer. Since machine language is, you know, universal, you can travel from computer to computer. You can go from the Apple computer to the Tandy and to what else? The Atari, whatever computers were out there, and ZX Spectrum, I think that's one of the international computers. It's transferable because what I mean by transferable is a lot of these things I'm typing, these are instruction codes, known as opcodes, and they can be used across the board in many different languages. So I see some people joining here, so I'm going to see if there's any chat going on here, because I can't tell what you guys are seeing or doing. But the whole point of this is to understand that I think the word is transferable. You can write stuff in code, and I'm not talking about basic, I'm just talking about machine language. And from one computer to another, as long as you know what memory is doing on that specific computer, or that 8-bit system, if I will, you can write programs from any computer. For example, I can go from the Atari computer to the Commodore 64 computer to the Apple computer, like I mentioned, to any computer, and just start instantly writing in machine code once I have the proper editor, machine, monitor, whatever. And that's what I wanted to mention. Probably the most important thing is to really make sure you have a guide, or it's basically a memory map of your system. Like, for example, right now, I'm looking at and reading from the Mapping to Commodore 64 book. Well, I'm looking at it, I'm reading. And that's where I got this memory location 679. So I know in my computer that 679 is a memory location that is unused. So actually, memory locations from 679 through 767 are unused. So you can write anything into them. You can use them to store temporary data or whatever. In this case, I'm just using it to store simple numbers to show you how the addition works. And let me enlarge this too. I always forget to do this. So hopefully that's a little bit better for you guys. Keep checking the chat to see if anybody's... I see people viewing and joining and jumping out. Jason, let me just see. Can you hear me, Jason? I'll just throw a message out just in case he doesn't have a microphone. I can never really tell who has a microphone. And if they change this in some way, maybe that's why. I like to try to interact with people as they join. I did send out a message. I think you're one of the retro people. Oh, no camera or microphone on my end. Oh, how nice. So, okay, let's clarify this. You have no camera, so I can't see you in pictures, and you have no microphone. I'll just say this. Can you see my screen and hear me? There we go. Okay, cool. See, I can never tell people can hear me. What I do is I have my audio set up directly through my speakers, but somehow my camera has its own built-in microphone, and it seems to pick up on my camera. When I don't have my camera hooked up, it seems like nobody can hear me, so I haven't yet figured out. My computer's very weird. But just in case I got both cameras here, in case one doesn't get it, the other one will pick it up. That's cool. So since now that you can hear me, and if you can help me out for a second, I haven't been in, I don't know how well or familiar you are with Google Hangouts, but I haven't been here in a good while, for about a year. So I sent out a bunch of invites to people, but I don't know if they've received them. Is there anywhere in here I can see that? Like if I go over here, control panel, or I don't know. I don't know how this works all the way. You know how the chat works. Because I always hate like creating a session and then getting back people's feedback later. Oh, I couldn't join it. I was like, okay, I sent out a bunch of invites and nobody came, you know. It seems like maybe it's the one spot I'm sending it that people are getting it, but maybe in the other area they're not getting it. I don't know. Google Hangouts just kind of confused me for a while. So what do you think, Jason? Have you used Google Hangouts before? Oh, first time. Okay. Well, I sent a message to you. I know I sent it to public so that people would come in publicly. This explains to people with views dropping and coming in. I sent it to my circles. I know that. And I've also got my YouTube channel up here so I can kind of monitor it and see if people are popping in and out, and if they write messages and stuff like that, then I can kind of see if somebody's trying to join or something like that. Oh, I got a message here. Oh, that's just the event starting. Okay, so yeah, I did it right from here is where I advertised it. So if you can't join me in the Hangout, please let me know here. So I'm just going to throw a message out there so people can kind of see if they're having trouble. I put the link. Did you get to the link, by the way, Jason, from here? Or did you get it somewhere else? The Google Plus page for your event. Okay, so you didn't get like anything on your phone or your email or anything like that? Like, how did you find out when I sent the message to you? A reminder email. So maybe when I sent the message out, it sends an email to people. I don't really know how that works. I know there's a way you can advertise on the YouTube page too, but it's been so long since I've done it, I can't remember how to get to it. It's supposed to be somewhere in here you go to and you can have a YouTube broadcast and while you're still seeing the actual video over here, and then people can start joining it as soon as they find it. But it's been the longest time since I've used this thing. But anyways, now that you're here, hopefully other people will join. If nobody joins after a while, I'll get a little suspicious and try to send out another email or some or message. Are you familiar with any 8-bit languages, like in general? Like, do you like the Commodore 64 stuff? I saw the YouTube ad first to some level. I've done some basic and some rudimentary assembly. Okay. So is there, the whole point of this, if you saw that on the advertisement, is for people who really want to know, like, and have questions about, like, stuff that they're writing, stuff, code they don't understand. I'm going to try to do my best to explain what I can. I'm not an expert, but I've played with it long enough to really understand how to write my own stuff in it. So is there anything like from a simple level, like trying to get started, or anything you're stuck on, like loops or anything in general that you'd like to go over? Where did I put my books? Because all I'm doing right now is simple loads and stores, passing values backward and forward. For example, most people learn how to calculate in assembly language first before they start learning about, you know, writing their own loops and stuff like that. And what's called a main loop, where it's a continuous loop that allows the program to continue to run without stopping it unless you set a command to break it out or something like that. So do you have anything in particular interest you'd be interested in learning? Okay, that's where I wanted to find out. Okay, cool. So I'm glad you can see that. That tells me what you're seeing and everything, and I guess it's large enough for you. So I was starting with, I didn't mean to go right into this. This can be like a step up from the beginners. Essentially, the main thing to understand is, do you know what first of all, LDA stands for? Do you know like an LDA versus a STA? Do you know what those do? Okay, so we're past that. And then these are I'll just put it down here in comments. These are the math, I guess you could say math commands or whatever. And the SEC is a set with carry. Oops. Start commenting this out. SEC is set with carry. And you have to set with carry when you're doing subtraction because it can involve not only positive numbers but negative numbers. So it sets the carry flag if it drops back to negative. Like if I tried to go like 20 minus 25, for example, it would take that extra bit and store it in the carry flag, of course. But that's why you have to use the SEC to capture that carryover. It's kind of like addition. If you think about addition, when you're doing the one, you have to carry the number. Like if you're, what's a good example? Like, let me see if I can get a notepad pulled up here to kind of explain that a little bit better. So going back to basic math, for example, and that's all this is basic math. If you wanted to do like 25, take a 1 with a carry, I just want to do like 10 or something like that. And then you have to do just the regular basic math. So, you know, the answer would be, actually, this is a bad example. I'm trying to get one where I carry. So what I need to do is this. So I have to do one where I carry the bit over. So 9 plus 2 is 11. And then you carry the 1 up here like that. And what am I doing? 9, 10, 11, 5, 16. Hold on a second here. I'm doing this backward, so I'm not thinking. So it goes the other way. So we need to make this the carry flag, not this one. The brain's backward here. So like this. So hopefully you can see that. So 9 plus 5 is what? 14. And then you take the 1 up here, what I meant to do over here, and you, sheesh, trying to insert it. And then you carry it over here on the top like this. So it would be what, 3? I think that's right. I just double check my math here for a minute. Where's my calculator? So 25 plus 19, 44. What did I do? Oh, I forgot. Got to carry the 1. So 44. Anyway, so 44 would be the answer, right? Okay, so this is like what the SEC or the CLC is doing. It's taking this 1 and it's carrying it so that the system will remember it. This is important, especially when you're doing very large math on the, whoops, you're doing, Notepad's not a good example for this, but anyways, when you're doing very large in the math and you want to go a number higher than 255, for example, when you want to get to the next carry bit, man, I cannot get this to work right. So if you wanted to, for example, add 255 and 1, we know that's going to be what, 256? But it has to carry the 1 because it can only store 255 digits in a low byte number. And that 1 is going to act as the carry bit, which is why SEC and CLC exist. You might have saw me write this with CLC earlier, like that. Clear carry. So let me leave this example back up here like this, for example. Oops. And then what we'll do is we're going down here and we'll say add CLC, which you're asking about, clear with carry. And then we'll create another set of commands down here for the math for this. So you're going to load in the value that you're going to use. I guess we could use I don't want to go into 60-bit math. It's a little bit more complicated. We'll try to stick with the 8-bit math from now. 8-bit is anything that's from 0 to 255, just in case you didn't know what that means. Anything above that 255 is going to go into 16-bit math because now it's got to start carrying values over each time, which is the whole purpose of the carry. But anyway, CLC, because we're doing basic math here. Oh, I forgot to put my number in. And I don't know, we could do any number like up to 255. So you do 200, whatever. That's totally fine. And then add bit carry 7. And we're going to store this into another memory location. We'll use 680 in this case, and then I'll run it. And we'll look at 680 this time if I didn't make any mistakes. Now, you probably already got this part, but to activate the program, since it's still operating directly within device, you have to run it like that, unless you set it up automatically to run. So now it's activated the program because it's in memory. If you peek into that location, I'm sure you probably know this, but you can see the values are stored there, and that's load the accumulator with 2 right there. So now we know that there's going to be a value stored in 680, which was our subtraction. So if you looked here earlier, you saw the result here, 207. We just go back here, and we're just essentially taking the 200, adding 7 to it, and store it in 680. So it's pretty simple for the math part. Does that make sense? Okay, this is, I'm going to switch back to regular mode here for a second so I can show you the book, so I can get back out here. So if I turn this, well, I don't want to lose this, hold on a second. Screen share. I think if I stop screen sharing, that's what, I don't want to lose you at the same time, and I wanted to switch back. Darn it, how do I get back here again? Let me see what happens. If I click this, it might shut the camera off. I tried to get my camera to turn back on. Oh, I think I had to click the picture first because I was clicking that, and maybe that's what I did wrong. Darn, it's been a long time since I've done this. What I was going to try to do is I was going to show you the book I'm using for all this. How do I get back to the screen? I know there's a cameraman here. I don't know if this is it or not. Give me 1 second. I'll see if I can switch this back to where it was. Turned on your camera. Muted microphone. Okay. So hopefully I didn't lose you there. Ah, man, I can't remember how to do this. It's probably really simple, and I'm just not thinking right here. But what I'm doing is I'm looking at this book anyway. I'm mapping the Commodore 64. Have you ever heard of that book? Okay, cool. So if you go to page 68, that's what mine shows. Look up memory location 679 and see what it says there. You can go ahead and type it out or whatever, because obviously you don't have a microphone. While you're doing, I'm going to check the Google check thing again here real quick and see if there's any way if people are trying to join or not. What does it say in the actual book, though? Like, it'll have the hex code for it, and then right underneath that, it'll say something right under the number 679 to 767. Assuming you're looking at the same book I am. I'm going to have to mute this for a second. See if anybody's trying to join here. Yeah, I don't know if they're going to find this or not. unused. So right there, anytime you see an unused value on the Commodore 64, it means you can do anything you want with it, even from a basic level. You can write values into it, and they don't get overwritten by ROM, essentially because ROM is writing values backward and forward on many other locations. Like you might have saw me using earlier, 203. On the Atari, you can actually use the 203, and I'm used to using Atari a lot, so that's why I threw out the 203 originally instead of 679. And then I realized my mistake, and I went back and corrected it. And unfortunately, it's used. 203 is used on the Commodore 64. It's something to do with the screen or something. I forget what it was. Matrix coordinate current key press, it says. So to answer your question, we can definitely use 679 because there's nothing passing through it. There's no values passing through it from the assembly language level, if that makes sense. And the values 679 to 767 are completely open. What's really nice is you can, because they're all open in a row like that, you can set high and low values backward and forward. I could use 679 as a low value and 678 as a high value. Hopefully I'm not going over your head with that, but those are what I was talking about earlier with the 8-bit versus the 16-bit math. That's probably one of the harder things I had to grasp first, was understanding the 16-bit math. And to be honest with you, I didn't learn it until actually I think it was earlier this year. It was either this year or last year. I think it was. Might have been last year. It was probably this year. I'm trying to remember the last time I was throwing programs out there. It was probably this year. And I met some guy on Lemon 64, and he really helped me understand how to write and how to calculate within 8-bit to 16-bit math. And I started doing some pretty cool algorithms after I learned it. So once you get into all that, you'll be using stuff like ROL or ROL, stuff like that, which is rotate left, rotate right. So I won't go into those. Those are a little bit more advanced right now, but it's all the same concept. So I'm just going to throw a little note here. So 8-bit math is 0 through 255. 16-bit math is 255 to, was it 65, 535 or something like that? Let's forget how high the values go. The computer is 64K, so it goes up to, pretty sure 655, 35. So do you have any particular interests in assembly language, like what you wanted to learn to do with it? What kind of stuff you want to write? Are you just curious, or what is it? Or somebody wrote in this book. While you're contemplating, I'm just going to try something different here. I'm going to erase this part. And just show you what's going on down here. Rerun it. Why does this thing always default to small? So I don't know if you noticed what happened here, but if you look in these values, 679 and 680, what it did is it took the same thing as doing this. Poke 53, 280, comma 15, or poke 53, 281, comma 207. Notice it didn't change the screen. Now I'll show you what I mean by that. So we'll use a different value so it changes the border color to something different this time instead of Yeah, this is because we used a higher number. Let's try 205, maybe that'll do it. See what that happens. It's passing in the screen colors is what it's basically doing. I wish I could get this thing to stay every time. Let's see how it's changed now to an ugly pink. You'll see the value is now near 212, and when it was originally, if we changed it back to 207, it'll go back to gray, put it back to 212, it's going to change there. So it's just basically taking these values in the accumulator and passing them into the screen. This is the, just in case you don't know, this is the border color, and this is the screen color. So whatever you change in here, we'll change this too. So if we change this to something else, you'll see this change. What happened here? Maybe that one wasn't a good example. Let me just test something here. That's that color. These values are probably too high. Let's stick with the lower numbers, I guess, for now. Because I already know the lower numbers, what they're going to store values in it. So if we wanted to change the border color like to a yellow, for example, which is 7, we could do 1 and 6 like that. And then we'll change it to a yellow. And then we'll maybe change this one to, what's some of the other colors? I think there's like a light green or something. So we'll do 9 and 1 here. And you'll see now it should be some kind of like a yellow. Let's see, a yellow and a green or something like that. Let's see if I did it right. Oh, I'm still off here. I'm off on my colors, but you can see it's still changing the color. So if you go back and you peek those locations again. Oh, wait. I miscalculated one of these. 671 is showing 251. Oh, I was subtracting. I was thinking this was adding and this was adding. This is really subtracting the value. So what we want to do to correct that and make that 7 would be to say 8 minus 1. And now it'll be a 7. That's got a large set. Okay, it's 632, 768. There it goes. So now the border is yellow. And then our other goal was to change this one. Let's see, this was originally, I was going to do 10. I think 10 was the color. 9 plus 1. Let's see what is in 680. That's 10. Let's be off on the colors. Maybe it's not 10, 7, 8. Maybe it's 11. 11 is a color. That's not the one. This is going, that's what I was looking for, 13. So let's do this again. And we'll do 12 plus 1. Now it'll be 13. Okay. Are you still with me? I couldn't tell. That's what I was trying to do. Does that make sense what I'm doing there? Okay. You want to try an example? Remember, this is interactive. So what I'm asking is there a program you wanted to learn to write, like a simple program? Scrolling the comments to see, that's a little bit more advanced for this session. I mean, do you have anything like from a simpler level, like learning like simple semi-language instructions? Because that's what I'm trying to do. Is I'm trying to keep it for people who are also watching the basic stuff, and then eventually we'll move on to the more advanced stuff. That's probably maybe a lesson 3 or something like that. Scrolling the Commodore 64 message, you mean like doing like what was called a marquee scroll or something? Yeah, and it also involves looping. So we're not into looping in this session because it's going to be simple when you first start out. Yeah, because you would basically be scrolling this screen, which is, to explain right here, 1024 to whatever is 23. You'd be scrolling within there. Like if I can just go back here quickly to Vice. Let me just erase this real quick. I forgot how 147 I think it is. So if we, for example, went up here and just poked something into the screen like an A or something, A is 1, excuse me, like an A or something, and then the next location, B, and then C. If you wanted to scroll that ABC, you would have to look and see what's in this location, erase it, and then move it all the way across the screen. Instead of scrolling the entire screen, because scrolling the screen, which you've probably seen in some of my examples, that's very advanced stuff. And beginners it would be totally over their head. There's be no purpose of even having a session starting off beginners and all of a sudden I'm showing them advanced stuff. It's like, okay, I'm never going to learn this stuff. Yeah, I can show you how to do it in basic, so I don't mind blow people who are trying to learn the semi language here. So I can't find my equals. So equals 0 to, what is that, 39 or something like that. And trying to see the easiest way to do this. You could set it in a string or something like that. So we'd have to, let me just dimension a string here. The SCs is not taken. And then inside of SC strings, you would store some data in there, a name or whatever you wanted in there. And where's that thing at? I'm trying to find the. I always have my Commodore 64 computer memorized. Vice wants you to know where everything is. So now we got like a message, and if we wanted to scroll that across the screen, wait, what did I do here? I need to switch these two. Then you would put it inside of here. Does that make sense? And you would be scrolling just essentially the SC strings, but you'd also have to set a delay or it would go too fast. So equals 1 to, I don't know, 50. You'd also have to position the text on the screen, because if we just do it that way, it's going to do something real funny, and I'll show it to you real quickly here. Watch what it'll do when I run it. Something really weird like that, because we haven't erased it. And we also are not repositioning it. You have to reposition it each time. It's the same thing in the semi language, except you're not going to have like a print statement where you can position things. You're going to have to use, you're going to have to put it within that range there wherever you have the text scrolling to, and then you're going to have to erase it and then redraw it basically in the new position. So as I said, I'm trying to stay away from that in this example because people might get discouraged if they think this is beginners and all of a sudden we're talking about very advanced stuff. But we can definitely, I'll keep that in mind, and later I'll work on writing a code for it. I hope that it makes sense of what this whole session is about. It sounds like you're a little bit more advanced than some people might be. Actually, now that you said that, I'm trying to look up those locations. You could actually position text. We could use that as a good example, actually. I think it's 211. 211. What's the other one? It's 211. I think it's 208. Shit. 214. 211 and 214. Those are the ones I'm looking for. So back to that example in Vice, you would use those to position the program. I'm sorry, the text on the screen. I think 214 is the vertical, if I remember. And you have to set a print statement in the middle. I know that. And then how far you're going to scroll, like that. Why is going so slow? And then we have to do the same thing for 50. You do the one, you have to do the other. So in this example, what I forgot to do is we need to erase it. So it says next X, and then 60 will be print spaces. That. See if that does it. Well, you saw it move, but we got the screen colored here, so we probably have to turn the color off here for a second. You might see it move now. Oh wait, it's not positioning it or something. What's going on here? Let's investigate for a second. Oh, I forgot to put the FCs in there. How stupid of me. Oops. There it goes. Like that. So there's how you do it in BASIC. Pretty straightforward. Now in semi-language, you'd have to convert this into a loop. So you'd set a loop for the X register. Then you would use the 214. Maybe this won't be too advanced to do it. You think this would be too advanced for people if I showed them how to do this already? Since you asked me, I could probably just do it to demonstrate it. Sorry guys, I don't see anybody else joining here, so we're going to kind of step up the pace here a little bit and see if we can convert this basic program into a semi-language. Challenge of the evening. So the first thing we need to do is we just need to create a simple register for X to store the value to tell how far it's going to travel across the screen, which will be 39. And then what did you say? They're going to be done by basically loading and storing one character at a time. Increment the address, do it again. Not sure what you mean by that. Do you have a program example you could show me what you're talking about? Okay. So let's set a challenge here for each other. Let's see who can write this first. You probably already got the general idea. I just need to think here for a second. So I don't know how to do a print. If I can remember in the semi-language. The challenge is trying to use this because you have to convert this print into a semi-language, and I don't know how to do that yet in the semi-language that I can think of. But I'm going to try it anyway, see what's going to happen. So we're going to, so we got our, how far we're going to move it over, 39 spaces, position. Really, that's all we need. We don't really need anything else that I can think of. And we're going to set the accumulator to 8 for the 214. And so we need to set a loop. So this is a label, guys, if you're watching. I want to step up here, but if you're just joining, guys, we're just going to create this little basic program we have on the screen. Hopefully you guys can see that. And we're going to recreate it, me and Jason here, to see if we can create what he wanted to try to do is do a scrolling example across the Commodore 64 screen, which is probably not too advanced. And then we've already got the location stored. We took 214, which is, to explain this to you guys, 214 is the current cursor physical line number. Basically, it tells you which line you're on. Are you on 1, 2, 3, 4, 5? So it goes vertical down the screen, is what it does. And I'm just reproducing what the code's doing here, or trying to. And then we're going to increment that. But first we need to position it on the screen, a message or something that we're going to store in memory somewhere. So we probably have to write it into memory before we can do that. I don't know how else we're going to get a message on the screen if we don't write it somewhere. Essentially what you're doing here is you're storing this into a string, and you're printing the string back out. Oh, actually, let me, I hope this thing didn't freeze on me. Here, so we're going to reproduce this string with the letters that we have. So you have to store it in there somehow. It's 4 characters. This is the way I've always learned to do it. And we're going to pick a memory location we can store it in. So down here, you'll want to create what's that called again? I'm not used to CBM. I'm thinking it's byte or something. I'm trying to remember. Anyways, we're going to say this could be like the message, and over here, the bytes that we're going to draw in there. Now these, you can't just go in here and write like this. I know the Atari has an S byte, but I can't remember what it is on for CBM at this time, without cheating and going looking at one of my other programs. So I'm just going to use individual bytes and look them up in the book, or just basically calculate them. What I like to do is go in BASIC and do this. Since we know when we poke 1024 to the screen like that, it's going to put an A. You want to figure out what value would be, for example, my name S, and you would just set the AXI value. I think you can do it this way. You get it? Oh, that didn't work. We had to do plus 32. What's that? Give me a moment to figure out what the plus is. Right there. Here's plus 32 now, plus 64. That's an inverse S. It's not what I wanted, but we'll just use that for now. But anyways, if you go like this, S plus 64, you can see the value is 147. That's the value that it found. So we could use that as the first one. We know the next one's going to be 148, since T is an extra letter in here. And this is a faster way that I use it with if you don't have a lookup for them. So we're basically taking the AXI value, which is a character stored in your computer, Commodore 64's memory, and seeing what value is stored there. So this one is 133, that's the E. And then we can get the V just by doing this again. 150. We already know the E is 133, right? So there's the bytes. These translate like this, if you guys are just not getting this right now. So message equals C to 7 is an inverse. Because I didn't feel like looking up the other codes. I could have just done probably 90 minus. Oh, anyways, let's just move on to this. I'm not going to bother with that. The whole idea is just to move it. So we got the values there. Now we're going to be taking the message and we're going to be storing it on the screen somewhere where we can see it. So we're going to load the accumulator with message because that's what we want to read on the screen. Now I'm just going to use one value for right now just to see if it works here. See if we can get it to show up on the screen at least. Actually, there's a book I have here somewhere. Yeah, there's a book I have here on the COM64. It tells you how to print values to the screen. Let me look that up real quick. You said cycle through the bytes? Yep, that's exactly where I'm going with it. But first I'm trying to figure out how to regenerate this print to the screen. They show this in this book here. So JSR, I think it's E716. I think that's it. And this indirect output to the screen. Was it E544? Which one is it? This is a more advanced section here. Let's see here. I'm just taking a minute to digest something in this book. Row number, column, plot subroutine. I think this will work. Except this is... Okay, let's do this one, for example. I don't know what the first one is for. E544. E544. There's register 12. The Y register 19. Here's our plot. So to commute the value we want to store, which we know is a message. To get the first digit, the first value, and then use JSR to E716. Hopefully it doesn't crash. Let's see what happens. This is supposed to print, if it works, it's supposed to print this S somewhere on the screen at position 12, 19, because this is an X and a Y value. And this is the 12 is the row number, and 19 is the column. Is that? Now I'm just running out of space on my screen to keep this chat open. Still trying to get to all of my regular stuff here. Maybe I just have to get rid of this or something. I don't think I need this section. Whoops. Did I just close it? Okay. So let's try this and see what happens. Hopefully I probably won't get an error message. I did. Invalid instruction. So it's not... Maybe we don't need the period after it. That's what it was. We didn't need the period. Okay, so going down here to double size again, run into program. Notice it cleared the screen too. I typed it exactly as the book showed it. E544, 12, 19. There's our FFF0, the accumulator with the message. E716, RTS. Can't figure out why it crashed. So to translate for some of the newer people here, I'm going to pull up the, we already have it here, the programmer calculator. So whatever you type in here, it'll show you the value. So E5, okay, I need to set this to hex, E5, 44. So this is the decimal value for it. And that isn't right, is it? Is it 58692? I guess it is. Well, let me look that up in the book here for a second and see what that memory location says. This is an older book I'm looking at, so it might be, this might be from the pet computer even, maybe. It says Commodore 64 on it. The one I'm looking at right now says Semi-Language for Kids, Commodore 64. So anyways, 58692. Initialize the screen, line link table, and clear the screen. So this one clears the screen. That's what this one does. Why don't we have a value passed into it in the book? I guess it just works as a clear screen, and these are the X and the Y registers. And then FFF0. Oops. FF0 is 65520 decimal. 65520. I don't know if that's in here. It's a plot. Read set position of the cursor on the screen. So this one is setting a plot. So it does work there as a plot to the screen. So it's going to take 12, 11, plot it to the screen. And this is supposed to throw the value up, but it didn't work. I wonder if it's because of this. Let me just kind of use their example. They just put 88 in yours. And duplicate what they did for a second and see what happens. There it goes. It worked. So apparently the value I was using wasn't reading the message right. I was hoping I could just read it from message, but it wasn't reading this right or something. I know I could go here and put in an X like that, and they'll probably get it. I do that down here. Should work. Unless it messes up with the X register. Let's see what happens. Why did it print an X still? Let me write some messages in here. Clear the screen. I'll tidy this up a little bit. And this is right to screen. No, that wasn't this one, was that? That was this one down here. Right to screen. This one is plot X, Y, which in this case is 12, 19. That makes sense? So now we got the X and the Y. We just need to move it. Well, first let's see if we can get our message out. We're only doing, and this still didn't work either. This did not pick up this byte for some reason. Let me see something here for a second. Might be because of this. I think I have an idea what it might be doing. So 147. Let's do an S. I tested that earlier. Maybe these are not translating right or something. I have a mystery. What is X? X is 12. Oh, that's why. So I see what's going on. I need to reload this. X was going to originally be 12, and this message is only, what, 5 bytes in length, or 0 to 4? So it was trying to read way over here off the screen somewhere, and it was reading garbage on the screen. There was nothing there. So now that I caught that, we need to go ahead and reload the X or Y or whatever you want to do. We could just make it Y. I think we can do Y. And then we would read the value to start it at, which would be 0. Should work this time, I hope. Nothing. Okay. Maybe we don't want the Y, maybe we want the X. Looking at X, get message, start down here, get the first byte. Write it to the screen. By the way, do you know how to leave this as a default? Because I always have to change this every time. I don't know if you can lock it on here or not. Grab mouse events. Maybe save snapshot image might do. Nah, that's not it. So that didn't work. Let me set it to 1. See what happens. Nothing. Let me just see something here a second. Yeah, so it wasn't reading. Something with these bytes, it doesn't like these bytes. Like when I set them like the 147, it doesn't translate them correctly here. So I guess I'll just have to look up the one that's for S. I can almost figure it out though. Like how far is S into the alphabet? S, T, U, V, W, X, Y, Z. So it might be like 85 or something like that. I mean, okay. Pretty close, it's 19. So 19 and 20. So this will be 19, 20, should be about 69, not 69, I mean 5. And the B would be T, U, V, so it would probably be 22. Like that. Okay, let's run it again. See if we get the S on the screen now. Should. Or we don't. I have no idea why it didn't write to the screen. So take the value X, which is 2, read message. This would be over 2012. It should at least show this 5 or something on the screen. Change to text white. What's really weird is when you put these values in, it wants to work perfect. But it doesn't like when you use this. Any thoughts? It seems like I lost you. So take what's in message, 19. It's probably not the right value. What if I put 88 in here? That'll work. That's what it is. All this time. That's why. So I have to translate these instead. Won't be charged 65. 20 will be 85. 5 will be 70. This would be 72. I don't know if you caught that. I found out why it wasn't printing the values to the screen. Because the values we were using were too small. We were using 1, 2, 3, 4, 5, but those are not. If you look in the character set on the Commodore 64, those don't print any values. So it's reading it as an axis, basically. I just lost you again. But I think we can get it to work now. So we got the first value printing to the screen here, which is the A. And we're just going to change that to the S. Oh, shit, I forgot what the S was again. Let me see. Maybe it was, that's the T. That should be 84, right? I really need to go grab a book so I can look this up. That's the T. So it would actually be, oh, it's not reading that one. Let's see. There it is. There's our S. Can you see that? Finally got the S on the screen after all this time. So now to print the rest of them, we have to loop through them so we can see them on the screen. So we're going to talk about loops here for a second. So to get this to write out to the screen, we already have them in memory. All we have to do is we have to go back and we have to reloop this over and over again until we printed all the values to the screen. And at the same time, we have to go back up here because we also want to position this, and we need to change this register, or this one, the X register is going to have to change. So this is going to be a little bit tricky because this is the X and the Y, but we have to increment this, so we'll need to store this as another number. It can get a little complicated. We could also transfer this to a value, but that might throw the other one off. We could do something like this. Transfer X to the accumulator, so it sets it into memory, or we could push it to the accumulator, whichever. Actually, I did that wrong. Transfer X to the accumulator. So X is already an X register. Transfer it to the accumulator, so it would show up down here when we go to position it. But it's still flawed because it's going to always keep 12 in here, and it's not going to increment 12. So the only way we can really do this is by setting it to what's called an absolute value. And let me demonstrate here. I don't know if I could do it. I'll just have to do it down here somewhere. So we'll just call it, I don't know, position Y or something like that. We just set it to 0, and then we're going to use these as actual values that we can iterate through. Does that make sense? Am I losing you on this? So essentially what I'm doing is I'm going up here, and I'm going to use this like that. And then we're going to increment through this position when we get down here each time when we're done with this, so we can get the next value in memory. Now we just went from beginner to advanced probably. But what it should do is it should increment the next position here. And we also need to store the value in the y, otherwise it's going to think it's 0. So down here we would store this as wherever we want the y to start at. What was it, like 15 or something like that? It was 19. So 19, 20, 21, and so on, because it's incrementing through this value to get the next position stored on the screen here. At the same time, we have to increment the x registers so we can get the next value here in x. But notice here we're always loading back to x, so this is a little bit tricky, so we probably are going to have to set this as absolute also. So we're going to need them both anyway. Position x is 12, and we're going to have to set that one, well, 0, excuse me, 0, so we can increment through it. Position x, and we're going to basically increment through the x register. So it gets each new x position. I did this when I did the Common 64 scrolling thing too. Now, we want this to loop for the first time, just enough characters to print the message to the screen, which is 0, 1, 2, 3, 4. So we're going to make x stop when it reaches 4. So it gets to a 4. Once it's at a 4, if we're not there, then we want to go back and re-loop. And this is where we're going to basically use this loop here. It might lock up. There might be something I miss here, and we'll see if it locks up. Anybody's going to always stop it and go back into it again. Let's see what happens here. It didn't lock up, but it didn't print anything else. Position is a y. Position x, message x, print to the screen, increment y, increment x. Compare it to see it's for exit. If it's not, go to loop. Oh, because we never kept a running loop. So if there's a running loop, otherwise it's just going to jump out here at the end. We want to make it go back up here. So we could do something like this. We could just say branch not equal to loop. And if it's an X register, let me think here for a second. Branch and back to loop. This should have worked actually, because it should be going back through it, unless I changed X over here somewhere. Oh, I changed it to 12 right here. That's right. Oh my gosh. So I need to set this to 12. Row number, column. This needs to be X2. We have to do what's down here. That was just going to restore a media value back in X each time. Let's see what happens when they do that. Oh. So I need to think a sec about this for a minute. So get X register, which has a 0 in it. Why did I start this at 0? It should have been a 12. Oh, I know why, because I got two different X positions. This one is supposed to be different than this one. That was my fault. So this one actually is going to be 12, and the one at the top, which gets the X position, is going to have to be its own area. I think I'll just do this instead. Position Y, I'm going to set this to X0. And this will be the 0. And this will be the 12 and the 19, which is this one up here. So this is going to load the accumulator with 12, load the accumulator with 19 to get that position correctly for us. So when it loops back, it keeps loading the correct values here. Why did I do this? I totally left this in here, and I shouldn't have left this in here. This is probably screwing me up the whole time. We don't need that. So this is what we're really supposed to do. We clear the screen. We set the X register to 12. We set the Y register to 19 according to these values down here. You guys probably can't see them, they're off the screen here. I can barely get them all on there. So, make this a little bit more clean here. And then this one is going to be what's called our incrementer. So it increments through the register. And let's try that and see what happens. There it goes. Woo! Well, we got an S moving. Did you see that? We need to get the T, the E, and V moving, but the S is actually moving now. See? But I think it's probably not loading in enough values to get the other letters here. That's kind of cool. I didn't actually have to create a loop for it either. So STEVE, load the cumulative the X, compare it to see it to 4, go back to the loop. I don't understand why it didn't print all the values out here. Increment X registers, probably because of this. But this would always print it to the screen each time. Position X0. I never incremented X0, that's why. So I need to increment X0 so we know how many letters are going on. I didn't catch that. Okay. Oops. So increment position X0 so we can move this from, where's that? Move it from 0 by counting these bytes 0, 1, 2, 3, 4. So that would be 0 to 4 bytes that we're going to print out. But we only want to make it do 4, so we don't want to make it go higher than 4. Now we have to make it always keep within those parameters, otherwise you're going to get garbage. I'm going to leave it on the screen first to show you what the garbage looks like. Show you why you have to do it this way. Oh, wait. Actually, didn't print garbage. Let's see. Increment position X0. Load increment position X0. Maybe we have to do it down here or something. It's going to matter where I put this. Probably up here somewhere is where I really want to do it. And we don't want to do it there because we want to start at 0. Oops. You catch what I'm doing? I'm actually trying to go 0 to 0 plus 1 as an example. If this was just called X0, that's what it would be doing, is we'd be incrementing through this to store it in here, absolute. So this would go from 0 to 4, therefore reading our message. But my goal is try to get it to read the message. I can't see my logic right now. Not yet. Let me just look at it again for a second here. So print the message, 0 to 4. First time we're going to get the first letter at X. But we're loading X back up here, so that I don't know if that's kind of, shouldn't affect this though. Because we're changing X right here. Unless this one down here just isn't working. I'm notorious for doing this too. Which I'm going to do here. Since we were using 680 earlier, I'm going to select the 680. We're going to take this one out for now. And we're going to write our value into 680. And try to increment through that and see if that works. That's another way you could do it. So we're going to take what's the value in 680, which starts at 0. And we're going to try to increment through that using this. I think that's right. Let's see if that works. We got some more letters. You didn't see it, it went really quick. There's just some logic thrown off here, but if I run it again, you'll see real quickly it's going to print a bunch of letters on the screen. You probably didn't see it went from, it printed our letters and then it started printing more letters until I got to H and then it stopped. This is why we have to set that loop to stop it once we reach our goal here. So you do something like this. I've done this in programs before. X0, so we're going to check the value in X0 and check to see where it is. Is it at 4? If it's not, then we can skip over our loop here, which will be like continue loop or something. Go to a label. Otherwise, if we're at the end, then we want to jump out of this and we just want to exit out. That might print it on the screen. Let's see. Not. I see you going in and out a lot. Do you have a good internet connection? So increment through the loop. Sensitivity +1. Oh, it looks like I saw you dropping in and out. It like say 1 viewer, 0 viewers, 1 viewer, 0 viewers. So I couldn't really tell what was going on there. So, are you following where I'm going with this? Am I going a little too fast here? My problem is I can sit there and talk about stuff, but not realizing where people's level might be on something. How we all learn things differently. So let's start from the top here, or this. This is just clearing the screen. You know what this command does, right? JSR? Okay. So let's jump to subroutine. It's the same thing like a go sub in basic. So it's gonna, this one is basically clearing the screen. It's jumping to a program in ROM that clears the screen. Real simple there. Okay, do you follow this next one? Or is there something in here that is a little bit confusing so far? Okay, you got that. So at least I'm explaining that, okay. Yeah, so it's setting the X, Y like it would in our basic program. So our problem is happening in here somewhere. I don't know, do you see any different logic to what I'm doing here? Yeah, we definitely did. But this is why I'm doing this for. I'm trying to stop it when it reaches 4 and jumping out of the loop. This is just off the top of my head trying to do a program without really trying to plan it out. Do you have any suggestions of something you think that might be a different approach? Just to kind of see where you are on that level. I always had trouble putting text on the screen. Well, now you know how to put text on the screen. But our next example is getting all the text to move instead of just one letter. And I couldn't go in here and I couldn't increment X and Y here because it seems to throw off this loop somehow when I'm doing that. I wonder if I could just like maybe write the message out before I do any of this. Let's try this instead as a thought. Like if I were to do it regular from a developer standpoint, excuse me, this would be X equals 0. Then we would load cumulative message, comma X, and then just store it. It's already kind of stored there in message anyway, so we have to write it out to another location is what we have to do. So like maybe this would be temp_x, and this would be message, like TMP message, while we're just using it for data storage. And then we would use this one. This would be a duplicate of whatever this one's going to be, basically. We can just leave zeros in it because we're going to write values into it later. And I mean, lose my thought here. So take my bytes, temp message, TMP message, and store them in the message. So now that they're stored into a memory. And then we'd increment through the loop. Set this to 4 also and do it like this. You just decrement the X register and then loop through this small simple loop here too. 8 bytes or whatever. If that worked, it should read in our bytes. For those who are watching, what we're going to be doing is read bytes this is a STV. Basically, we're just reading all those bytes into memory. I should do it 2 on there. And then we read them in the first time, and then we might be able to just play with them here, and then we don't have to do all this looping stuff down here. We just take this out. And now we just want to increment through the position, since all we're doing here is we're clearing the screen. So we can leave it clear on the screen for now, but there's probably another way to do that later. Anyway, so position X and position Y, we're going to increment through our X as we're printing the values to the screen. We know that they are now stored in message. So we should be able to get them out to the screen successfully now. And I just need the other JSR in there. E7 and 6. And read the bytes in memory. Wonder if that'll work. Increment through X. And message would start. And then we still got this problem in this again. Load the cumulative message, comma X is going to read whatever is at position X, which is 12. Oh, that's right. We don't need we probably don't need that. So what I'm trying to do is I'm trying to read the message starting from 0 to 4, so I can read all the values in the message. That's why I did it that way earlier, because we had 2 different loops, and you only have an X and a Y to work with, unless you're storing in temporary storage like we did right here. Message, comma X, this will be the STEVE message, write out the bytes to the screen, increment, get the next value, and go back through the loop. Of course, this is going to start at this X right here, which is going to read this position X here, which is going to start at 12, which is going to probably put some funny bytes on the screen. I'm going to run it anyway. Just curious what will happen. Crash. Oh, it's doing the same thing from before. Actually, we kind of duplicated what we had before. That's interesting. We no longer need this stuff. Get rid of this. And we don't need this. Because it's doing the same thing. It's just incrementing all the way through X. It's going, if you're doing this increment X like this, for example, it's going from 0 to 255. So that's why you're seeing all those funny characters. But it's erasing them each time because it's clearing the screen here. So if we left this line out, I'll show you what it's really doing. Watch. Oh, clicked it. Yeah, I got an error message. What is the error message? Invalid operator label. Oh, got the comma. Comment. What do you think is going to happen? If I print garbage on the screen. Or it'll crash. It crashed. That's interesting. I wonder why it crashed. Yeah, it's crashing somewhere. You do not see any results. It's crashing. It's going through here. It's probably running into a floating point problem or something. Stack problem. So if we put this back in, it's going to work. Like it did before. Why did it do that? Alright. Wrench is not equal to loop. Probably because it's not getting out of the loop. I'm just trying to get it to print and clear the screen before it reads the loop. It's crashing every time. Load message comment X JSR to the screen increment branch slot equal to loop. Still crashed. Position X, position Y, 12,19. Maybe I took out some other command. Wait, where's my message for the... Oh no, it's there. So somewhere here it's getting stuck in this loop. So if we take this out, it won't crash anymore. See? It's getting stuck in this loop here somewhere. Because this is always going to load this back into X. And we're never loading it back into X here. It's always going to remember what's in here, which according to this is 12, which is going to be way off of this screen here somewhere. So it's like we'd have to set this in its own subroutine or something and run through it. X, Y. 5, 6.8, 12.19, because we're only going to be using the X. Increment through the X. We never incremented this either. We definitely need to do that so we can get the next value in X. Increment to position X. See what happens now. It's not crashing anymore. We'll start at 12, 19, gets the plot on the screen, reads the message. This is our problem job right here. Yeah, I keep having to move the screen down because of the error messages. Let me just move it up here. I'm going to shrink it a little bit here. You can kind of see it all there now, most of it. So do you see what I'm trying to do? I'm not trying to repeat the X and the Y loop. I'm trying to reuse it. But at the same time, we could do I don't know if there's an example in this book. Let me look. Actually, there is. Yeah, there's actually an example in here. Let's see. DSR clear, 0, message. They load it into the X. Wait, you can do it all in the same place? Really? I didn't know that. FFD2. Oh, so apparently there's different registers. I'm going to go ahead and put some more code in here. We're going to set this to this one, keep track of this one, and this one to this, like I show in this book. So the first thing they do is they clear the screen. I'm going to follow the example in this book so I don't sit there and waste so much more time. Load the accumulators 0, message out. So they're doing this all in the same loop, it looks like. Jump to read. So let me erase all this again. Up to here, I guess. So that we clear the screen. This is what they show in this book. We're doing it all inside the same loop, it looks like. And just down here. In their example, they're reading the Commodore. Kind of similar to what I was trying to do, but I didn't want to use all these jumps, but that's what they're doing in this example. So jump to read. I don't know. Is that doing that? Oh, because I got that up there. Come to read. Except we don't want this. Leave this at read bytes. And this will be called something different. Read. So jump to the loop. When it's done, exit the loop. So here they're able to somehow put it in the same loop, and this is just going to print the message to the screen. That's what it's supposed to do. So fortunately, it's not going to position it anywhere. And it didn't print it. Why not? E544 FFD2. So I typed it exactly as they showed it. It still doesn't work. So they're making it read 8 values for the common message and print these out each time. Increment, once it's equal to 8, it ends. So it should be printing these to the screen. See, this book is so old, so I don't know if this is for the old chips or the newer chips. But I typed it in exactly as I showed it. E544, FFD2. Branch not equal to read bytes. This is just my regular reading bytes. That shouldn't matter. Oh, there it goes. It printed something funny on the screen now. UHF, UFF, UFHF. That's weird. They said printed something. That's what it's supposed to do. It's supposed to print a message. Oh, because my message has zeros in it. Duh. So I wonder if I can do it this way. Not sure if Device will, or CBM allowed to do it this way. I learned something. Nope, I didn't think it would. There's some kind of directive or something you can use to print like this, and I don't know what it is in CBM. I've always used just the bytes for it. Data types. DCB. There's a text. Maybe I could use text. See, bytes always just going to do the comma. You can only do individual bytes. bits. That's interesting. So I guess this is text. Oops. See if that works. Oh, but we're passing in this value too, so this probably has to be text too. I don't want to lose those values again, just in case I need them again. Because earlier we were saving the temporary message, so we want to keep it the same so we can use it later. What the heck? Alright, let me just erase this for a second. Nothing. How do you use it? I was looking at the help over here. Yeah, you can. I thought you didn't have a camera hooked up. How do I pass you the screen? Then go ahead and request it. Thought I had to pass it on to you though. Man. Whoops. Yes. I can see your screen. So you're showing like how to write it to the screen? Yeah, I'm familiar with that process. I was trying to use the JSR plot XY, which I think is faster. Or what did I do? Yeah, I have the quotes on it. Do you have Vice on yours? Do you know how to hook up Vice? Or do you have it downloaded? Run it in Vice. I only see your picture. So it's only showing your picture, but I'm not seeing the Vice. Everything disappeared when you ran it. Because when you share the screen, you don't want to just share CBM, you have to share the whole screen. Not yet. Now I see it. You have to click on it because I'm seeing your. There you go. Yeah, that's how you print it at the top of the screen. So that's how. So I wonder why this didn't work. And it's printed as UFHF, whatever that's coming from. I couldn't figure out why mine wasn't working. That's how I have it over here. Here's what mine looks like. But for some reason it didn't work. So message comma X reads this. This prints it out to the screen, waits till it reaches 8, which is linked to the message, ends when it's at 8. Otherwise, it goes back to read and rereads it again. That's what the book shows. It's not working for some reason. Now I get why this is not reading this. When I exit this out, it's not reading this for some reason. Yeah, I'm going to lose the thing if I do it again. Well, at least I realize what's going on. When I put this in earlier, this is what reads it to the memory, and it's allowing it to print this, but for some reason, this message is not reading this down here at all. Although this one reads it when you store it in the message. I don't know if I need to store it in a message. I don't think that's going to matter. Like I said, this book is old. What did I do earlier? I did E544, E716 for the out. Let me change that back to E716. Just to see what happens. Nope. Nothing. Doesn't do anything. This is the only thing that happens when I run it. Now it's not doing anything. It just turns the text white. That's all. That's it. So it's because these values are empty. So if I put something in here, it'll read out whatever I put in here. If I put 65 in there, it'll print out 65 or print out A on the screen. It's just not reading those values. It prints all A's there. It just doesn't like when we're passing in the other one. Because we're reading it at, should be starting, I mean, if I push this to 1, I don't know if it would matter. It's supposed to start right here and read right through all the bytes. It could be it starts at 1, but I wouldn't understand why. Wait a minute. I thought I saw it. The caps? I don't understand. What do you mean by caps? You mean this because this is all in capital letters? Well, I did that because these are going to be higher values. These are going to start like 120 and so on. We could probably do that just to see if it works anyway. It's a thought. Nope. But notice when we did the immediate value, it works. It's something to do with probably where it's positioned in this X or something. I was looking for why the other one worked, but this one didn't. Load the cumulative X. X register starts at 1. Compare it to 8 and commit through X. We could also do this. Decrement X. Compare X. Print message. It was. Let me see something here a second. Oh. We're going to change this one too. Well, we could definitely do that too. You're asking me to look at the status registers. If I can remember which one it is. It's been so long I used this, I forgot how to do this. Let's see. Open debugger. Yeah. So right here, I guess we can keep that while we're running it. See what they look like. Why didn't this work? I know there's one built-in device too. I always use one device, so I can remember where it is. It's been so long since I've done this. Emulation. Should be a debugger or something. Where are you? You don't know where the debugger is in Vice, do you? I totally forgot where it is. Maybe it's over here. Many times I used to use this all the time. Refresh maximum warp full screen. Oh well. Guess there isn't one in Vice. Thought there was. Because these aren't working because the program counter should be set to the value in the program, but it's not showing what's. Oh wait, we forgot to do. Oh, we did that earlier. But when I run this, like this doesn't reflect what's going on over here. So I always used a different one before. I can't remember where it was. Basic loader. What's memory viewer? That's not it. That's what I did have open. A character set. Where are you? Where are you? This doesn't show the status registers though. It shows the memory. You think something's wrong with the character out? That's what the book shows. The book shows FFD2. Yeah, I'm wondering if this is because this book that I'm looking at, let me switch back to full screen to show you what I'm doing here. Now I know how to do that. This is the book I'm using. My camera's not too great, but can you see that? It's a CBM language programming for the Commodore 64. And it's a very old book. I won this on an eBay auction recently. It's 1984, so it might not be for the Commodore 64. Even though it says Commodore 64, maybe it's on the old chipset or something. But when I used the plot example, it worked earlier, so go figure. Which is why I hate referring to that thing. Let's see what the map in the Commodore 64 says about that. Yeah, obviously we are. But you saw earlier it did print some text on the screen. Matter of fact, when I do this, like I showed you, when I change this just to a number, it will print on the screen whatever I put in there. If I put 66, it'll print B on the screen. Just all B's. See how it's printing the screen. It's just not printing from the label that we're trying to print from. That's our problem. So it's probably something to do with that text somehow. The way this is being read is not translating this correctly. That's why I never liked this text one. That's why I was using bytes earlier, because I never really understood CBM from that perspective. I've never used this editor very long. I used to use C64 Studio and other ones before this. So that's good thought, but it's probably something to do with that or something. It's certainly interesting researching it, though. So what I was trying to do is figure out the values that we're printing in memory. I was trying to look at the stat to see what the status registers show. And I can't remember. I think I ran it in Vice before or something. Maybe I clicked up here somewhere. And it showed the exact registers every time it ran. I'm pretty sure it was in Vice. I don't know how familiar you are with Vice, but there's a way to show the debugger here, and I cannot figure out how to do it. Or maybe I got the wrong version. Doesn't like any of those. Probably in settings somewhere. Save settings. Cartridge. I don't see debugger in here anywhere. My help doesn't work. Let me go up here for a second. See something. Make sure this is enabled. I got too many of these open. So here's the debugger. Use Vice debugger. Ah! I knew it! We didn't have it registered. This is so crazy. You have to turn on device debugger. Oh my gosh. Oh, it should show up here now. Question is where? I didn't see another menu pop in here anywhere. So maybe it'll work now when we do it over here. Maybe that's the key. Where did my debugger go? Let's try it again to see if it works now. Now that I activated it. That's just crashing. Okay, so we're back to this. Now switching over here, run program. Let's see if it changes. Nothing. See, it's not picking up the program counter. These are all empty. So it's not working right. What if you have to set it or something? The byte numbers. Oh, right here. You did that one. I'm going to try to figure out how to get this debugger working. So I just shut this down again. Play with these tools again. Make sure it's connected. Use CBM Prg Studio debugger. That's what we were doing earlier. Use Vice debugger. Assembler. Variable label to window to output. Assembly none. Brief full to window. Let's see what that does. Whoops. Oh, come on. What happened? Where'd it go? Got an error message. Oh, wasn't paying attention. So this just shows like assembly dump. That's all that's for, so we don't need that one. Label and variable dump. So we don't need that one. We can turn that one off. We don't want that. Output. Use Vice debugger. So you can't use the text on that. I still would like to figure out how to work that stack thing, but or the status registers. But so if we put this back to bytes, like we had earlier, it'll probably work. Now we have to do it the hard way, I guess. Oh, that's curious. Let's do that and see if that's what this does. Maybe that's... Maybe it was working all along. Maybe I had that character set data wrong. Okay, we got to change this again. That makes sense because there are character codes. Oh, so this is wrong. All this time it's the text is wrong. So I got the data values wrong. Okay, I'm looking them up now. I just noticed they're in the back of this book. If you go in the back of the mapping Commodore 64, they're in the Appendix F, in my book at least. So I'll be able to get this really quick. But the 83 is showing the XE value, but it might be that we need to use that one. And that one. And where's the E? Wait. What am I doing here a second? It's 69. It's supposed to be 83, 84, 83, 84, 69, 86, 69. Okay. So why is it doing the same thing again? You got fate shop? Let's test something here a second. Oh, I changed the first letter and now it almost read them all. That's really weird. Maybe it's not, it was never reading the first character, that's why. Ah, I got it. Got to change this. No, way is off here. Oh, we got too many letters here. 0, 1, 2, 3, 4. Zero, 1, 2, 3, 4. I think it's reading this first one now. Not reading the first letter. Maybe it's not going out far enough. Yeah, that's what it is. Got to read that first letter first. So put 83 back in there. We got it. We got it. Teamwork. Teamwork. Oh, why is it reading the E now? Zero, 1, 2, 3, 4, 5. TEVE. Let's see if it's reading that letter again or not. He's putting an E in there. Every time I change it, keeps sticking an E in there now. And E is 69. So it's like it's not reading this first value. It's only been TEVE. We go 0 to 5. This is really weird. Any thoughts on that? Is it back to a 1 maybe? Do we have to start it at 1? I do that, it releases the first character. When I put this back on, it reads the first character, but it's not reading this 84, it's reading something else. And I can stick anything I want in here, and it still won't read it. The joys of assembly language. You wonder why it takes so long to write a program. See, it's only reading 4 characters. Zero, 1, 2, 3, 4, 5. These are always the mysterious part, is trying to figure out these directives and how these work down here. This mystery stuff down here. Any thoughts on that one? X register. I'm going to flip it backward, try it that way again. Look at that. Went bizarre bazooka on me. Like it kept going all the way through 255 characters when I set it to 5. Oh, because I incremented the X. My bad. Okay, isn't that interesting? Look at that. Now it's reading 2 bytes past and it's putting a T and an A on the end. What's up higher? It's just the directives. The label names. Start at 5, go to 0. Now it reads the T. Very strange. Back the way it was again. Let me save this again. And do something different here a second. See if it gets the ABC there. Well, this time it worked. It read the ABC, unless I just have the letters off or something. So it read the ABC. It's always going to start at the byte, even if you're starting it at 5 here, it's still going to read in the message, so it's always going to start where messages by reading here, but it doesn't read it actually backward unless you decrement it, because if you're incrementing through it, it's still, or if you're decrementing through it like this, like we were just talking about, and you set this to 5 and you set this to 0, it's still going to be able to start this at 5, but to explain it, it's still going to start reading to this and it's still going to count it backward. It's just how the loops kind of work. That back the way it was. I see your point. Let me make sure I put this back the way it was. So we got the ABC. I'm going to do this one letter at a time now. Maybe I'm just not using the right ASCII characters or something. So we put this as an 83. Especially why I hate using bytes. Hey, look, I just changed it to 83 and there's still an A there. What the world? '84, '84. Let's see if it does BBC. This is a mystery. Now it's just reading ABC again. Erase some of this other stuff. Make it a little cleaner. Start at 0. If I start at 1, it's probably going to get the B. We're going to do this time. TCVE. Try you be any number 5 instead of range is equal. You mean change this to branch not equal? Like that? Well, you can't use number 5. You have to compare what the value's in it. It's always going to compare against the previous registers. You can't do this. That'll give you an error message. You have to put a label in there. But I see what you're saying. See what happens anyway. It's like it's repeating what I just did earlier. I'm telling you, bytes do some really strange stuff. I've seen them do strange stuff before. Which is why I was really hoping to get that text to work. It's so much easier just printing out text messages. I don't have enough experience with this part. Okay. Let me give you the screen again. How do I do that again? Does that give you the screen? Oh, you have to do it. What if bytes don't read the ASCII character? I can barely see your screen. Larger text. Can you make your text bigger? Just, you click in the side device, hold down Control, and if you have a middle mouse button, you roll it up and down. There you go. So you set that to 0. And message X, JSR, F52, compare to 5, okay, branch not equal to loop. That's what I get for using a dumb example in the book. That's how I would normally do it. I think the book is so basic, it's showing people how to do stuff very basic, instead of showing the more direct way of doing things. They repeat a lot of the commands in the book too. It's like directed at kids. But yeah, that's how I would do it. And that'll probably work good. Well, we don't want to go to loop here. I need to go to read here. But I got what you're saying. Let me go back to my screen again. Whoops. Got an infinite loop going on here. Did you get an infinite loop when you ran yours? Oh, I forgot to put the increment. You've got to put the increment in there. Did you put the increment in yours? Maybe you did. Maybe I overlooked it. That's printing 255 characters. Okay, why is it doing that? Start at 0. Compare it, see if it's a 5. Increment X. And this has to be above here, actually. Can't put that before. Bad practice. Bad writing. Stop printing too many characters. Load the cumulative message X. Increment X register. Well, we probably don't even want to do that. We probably just want to set this down here. What you're doing is you're first going to write the characters out to the screen. Or whatever is in there. And then when it gets the first one, it's going to write the S to the screen. Check to see if it's a 5. It's not. First time through the loop, it's going to be a 0. And it's going to go back up here because it's not. Read the next value, which should work because we incremented the X here. But if we just do this, it's not going to increment the X. That's the problem here. So this is why they did this. So you can exit out the loop. I think that's why they did that. I'm never getting the letters again. I just probably don't have the letters right now. It's giving some really weird letters on the screen now. But these are identical to each other, so that makes sense. So maybe we're getting somewhere. 84, 84. Ah, I'm finally getting somewhere. 83, 84. Let's see here. Might have been it. Do we have it? Oh, we're still missing the first letter. I know it's 83. It shows me right in the book. It's still not getting this dang first letter. S-T-E-V-E. Let's go back to Vice here a second. I'm going to see something in a second. because this is reading AXI values to the character to the screen. And when we do that, oh no, it's not reading AXI values. It's minus 32. Plus. Oops. Oh. Okay. Okay, I wish I had a better book than this one. Let's see, these are the AXI codes. Maybe there's screen codes in here. Oh my gosh, did I not see this? And these aren't right either. I don't think. The same numbers. 83, 84, 69, 86, 69. There's the Common 64 key codes. That's it. That's everything in the whole computer. It's something that's flawed with the logic. Because I can go in here, for example, and I could change this to number 83, and it should print the S's on the screen. And all S's. Or not. See how it's printing all S's on the screen? So that shows you that it's getting the right character. It's just not, it's not like in this byte thing. Let me go back and read about byte again here. Can we actually do it that way? Does it accept commas like that? Oh yeah, it's right there. So it takes commas. Decimal, hex. Looks the same to me. So let's go back and do the logic on this again. So we're set it to 0. Read message. Should get the S. Read out to the screen. See, is it a 5, 0, 1, 2, 3, 4, 5? Not equal. If it's equal to 5, means we got through the loop, then read out as increment of next value of X. And its branch is not done, then it goes back to read. So, oh, it looks good. So I'm going to set this to 1 again. I'm going to shorten the bytes. I notice another thing it's not doing is it's never exiting back to the basic. So it's like the loop is being trapped here somewhere. But we can come back to that. Oh, I should have wrote down those values again. One, two, three. It's only reading 4 there. That's what I thought. So we have to leave that as 0. Whoops. So it reads all the values, and it should only be 4. Zero, 1, 2, 3. Let's not read the next one over. 0, 1, 2, 3, 4. For instance, they go to 4. Oh, wait. Oh. I never exited the loop. Duh. That was my fault. Now to go back. There it goes. Look at that. We got the first 2 letters now. Don't tell me this was it the whole time. I think we got it. You know what it was? Watch. It should work now. There you go. You know what it was? You know what it was, Jason? See if you can tell me what you think it was. You got it. Yeah, it never exited out to basic, so it was constantly trying to read this over and over again. Somehow just screwing up our bytes here. But now that we're exiting back to basic, it's able to read them correctly, so it worked perfect. At least for the printing part. Just to print stupid values to the screen. I'm going to save this code because I do not want to repeat this mistake again. I get a habit of saving screenshot code examples. Locate my code here. What are you saying now? How about 10 print Steve? Oh. So that's how we get the values printed, but that's going to print them to the screen. So what we still want to be able to do is move the text over on the screen. That's the next trick. But we know how to exit out of the loop now, so we've got somewhere so far. We have to bring in that plot and XY stuff again, which I think I lost the page again. So at least we know the code in the book works. This is my dumb error. And those are the exact mistakes. Okay. Yeah, we'll save it for another day. That's good. That's quite a good stopping point. But those are the exact mistakes you can make. I guess you left the screen here. For those who are watching, those are the exact mistakes you can make in assembly language. Something like that can, if you have like a massive program going on, you could run into a lot of problems if you're running into problems like that. Lockups, and just things not doing what you want them to do. This is why I was trying to show you guys how to read the status registers. We'll probably go that in the next video because I need to remember how to look, get them working again. But that'll be the next session, I guess. Link good basic examples, old school gaming. Yeah, I'll check that out. That sounds pretty cool. I've seen this before, actually. I actually found this before when I was looking at learning how to scroll and stuff like that, which I'm still getting criticized on my scrolling, so I won't even go there. But yeah, this is actually some pretty cool examples. Is this where you got some of your examples? That is not basic. That is not basic. So look at the assembly language examples you're saying. Yeah, pretty cool stuff. I'm going to put that back on a favorite again. Maybe one of these days, I won't say it too loud, but I might get that game finished. That game was complicated. I still don't know how to scroll a screen in all 4 directions at the same time. That was my biggest problem with that game. You don't want to know how complicated that stuff is. It's complicated. I can barely write Steve on the screen. Well, that's how you start. And that's the whole reason why we've done this tonight, for those who are watching also, is because you got to start with the basics. Like if you want to, ride a bike, you have to first put on training wheels, and then from there you eventually take off the training wheels. When you're a kid, I had training wheels on a bike, and eventually you get rid of that, and you start, advancing and trying more and more stuff. The main thing is you just try little things at a time. What I did to get where I'm at is I would constantly build routines upon routines upon routines upon routines until I really started understanding what one did, then I move on to the next. My problem is I can get too excited and jump over something before I've completely learned it, which happened when I was doing the interrupts. So I've never really gotten good at those. But I've got a whole assembly library here of books now. You probably saw the video on my YouTube channel. I won an eBay. This is the most awesome thing. I won an eBay auction of 34 Commodore 64 books. I put that video on it, and I paid a little bit of money. Somebody hiked up the value at the last. It was originally going for like $60, and at the very last second, somebody hiked it up to $182 or $160. I had to hike up my eBay bid higher than that to win, but still, $38 for under $200. I thought that was a steal. I mean, who could ask for anything better than that? It was just, I've got probably every Commodore book I ever really need. There's a bunch I showed through the video. So if you haven't saw that, go ahead and watch it. Whoever's watching, if you're still there, Jason, go ahead and check it out. I show each book and I give a screenshot of them and kind of explain it. Oh, you still saved them when you was a kid? Yeah, I had a few left, but I don't want to say this too loud, but there was a time in my life when I parted with a lot of my stuff and actually threw away a lot of my stuff. I regret that to this day. You don't want to know. I actually threw away a lot of software games, console units, everything, because I thought it was just dated material. Like probably other people have done that in life, I don't know. The biggest mistake is I threw away a lot of programs that I can never recover again, which is why I put those videos up on me trying to load data from cassettes on the Atari examples, because I was hoping to get some of that data back, but it's gone. I can't retrieve it. So what's gone is gone. You can't get it back. You just have to start from scratch and start over, which is why I got these books. So awesome stuff. Oh, Compute's Gazette. Yeah, I love Compute's Gazette and Compute Magazine. Compute Magazine? Yeah, that's right. They had a Gazette and they had the Compute. I have the Compute magazines. I don't have any Gazettes left, but they had a good eBay auction going for issues 85 through 89. I was going to jump on that, but at the same time I was trying to get the Commodore 64 book, so I passed on that one to get this one, which I was still glad I got these, but I would have liked to have gotten those two, but the Gazettes really got some good programs examples. And you know about the bombjack.org, right? You can go there and you can get the PDFs free. I mentioned that on my channel too. You just go to bombjack C64. I just type it in that way. It'll be right here. You can get all the books here. Probably every book there is for the Commodore 64 right there. There might be a few that I've gotten that are not even on the list, but a lot of these, like I have this one, and one of these I think I had in here. But the really cool thing is I got a lot of the semi-language books. I actually got this one too. I think I got that one. There's still a lot of them out there that I don't have, but, you know, really cool stuff. But if you need them, they're all there. So when I was learning the scrolling, I actually started going through and reading a lot of these books, especially like if you go here, the links, you click on the links here, it'll take you to that section. I got this book right here, and I want to really get through this book and read it. This is a really good book. As I started reading this thing is really got a lot of information in it. I would definitely recommend, well, this one is really cool, Jim Butterfield, but this one's got a lot of really cool examples if you want to go into game writing like I do and stuff like that. Really good examples. So download that and look at those PDFs. It'll take me a while to download it here, but really, really cool stuff here. Now it's going to take me forever to open up mine. I don't even have a PDF document on here. I'll have to open it up in Word or something. Oh, it won't work in Word. Well, I don't think it will. I don't know, it froze. Hey, get off my screen. My Word just froze. I don't have a PDF reader on mine. I need to get a PDF reader. Download one, because I haven't looked at any PDFs since I've gotten all these books. But anyways, this is a really, really good book. I think I have this one too. If you want to know about how the ROM works on the computer, check this one out too. The Commodore 64 ROM assembly. It's got some assembly language dumpings for the ROMs on the computer. So you can see like the basic subroutines. You can see some of the floating point subroutines. Anything that your computer is basically doing. Even some of the DOS is in there. So really good examples there. I like that too. I use that when I'm trying to find out what a certain register is doing. Like, for example, we were looking up that E544. You could easily go in here and look at it and be able to see the code and read what it's doing there. I need to download a PDF reader to this thing because it doesn't want to read anything. Oh, there it goes. I guess the other one just didn't work. So this is it, anyways, for those who are watching still. You can go up here, you can kind of search it. I just searched through here, E544 we were doing earlier. I don't remember now. Let me see. I think it was E5. Yeah, E544. If we wanted to see FFD2, let's do that one. FFD2. FFD2. And it'll take you. Let's go search through this. Or we might have to go up here and find it this way. You see what it's doing is it's reading, it's showing you all the code that's going on inside of your system. It's really cool stuff, guys, if you're watching here. Oh, it's actually below E, EF. Looking for FFD2. And we'll call this one a night after this. So FFD2, I just wanted to show this to you. FFD2, because this is what we were doing in this example. I hate having to do it this way, but the way at the end here. FFD2 should be up here. FFD2, where are you? Right there. So right there, that's the one we were doing earlier. And this is what it's doing, is it's jumping to this routine. So it's doing an indirect jump to 0326, which is high and low bytes that are found in whatever 0326 is, and I'd have to convert that to find out. 0326, whoops, I need to do the X one. You just click on this and it'll switch to that one. Where's the clear? 0326, so it's registers 806 and 807, and if you want to really be technical and go into the Commodore 64 memory map, you should be able to find what those are pointing to. Those are pointers. 806, 807 is vector to kernel CHR out routine. So let me switch over real quick to the video and then we'll end this and I'll show you what I just did there. So remember, what I just did here is I was, to those who might be losing me here, I'm looking at this routine right here, which we were using to print out to the screen here. And this ROM disassembly here will show you right here what it's doing. Let me enlarge this a little bit to show you. You see right here, what it's doing is it's doing a jump indirect to 0326. So I went here to my calculator to convert the hex to show you to decimal. What it is 326 is actually decimal value 806, and I'm going to switch the screen and show you what registers 806 and 807 do. So it's reading high and low bytes of 806 and 807. So if we go back here, I'll show you in the book here. You might not be able to see it because this camera is horrible, but 806, 807, I'll do the best, see if I can get it to zoom in. I'm just going to zoom in. It's right here on the bottom. Man, I wish this camera would work right. I had a much better camera before, but what it's basically doing here, it says vector to kernel CHR out routine currently at 61898. And that's exactly what we did here. We vectored to this register right here in CBM, which is CHR out, just like it says FFD2, which is printing to the screen. So that's basically what it's showing you to doing. So I guys hope you guys enjoyed watching this video. I know we only had one person. I don't think there was anybody else trying to join. And I apologize if you're having trouble joining. I only got 2 people, because I haven't just started this up in a while. I only got 2 people that responded, but they said they didn't think they'd be able to make it on a Saturday night. So I hope you guys enjoyed this video, and please like and subscribe. And yes, this is Steve Morrow signing off. Have a good night.